evening, guys. So from today onwards, we are starting with the DSA and STL concepts. Okay, so let's start with a simple data structure. That is, our data structure is two types: linear and non-linear. Linear, we have like linked list, doubly linked list, vectors. These are the example of linear data structures, as well as non-linear data structures are tree, maps, okay, dictionaries. These are non-linear data structures. So today we are going to start with a linear data structure called linked list. So first we will start with the simply linked list, how the linked list is created. Once that is completed, we start with the C linked list, how the C way, how to write the linked list in C++. We will start with that, and then we convert that C linked list into C++ linked list. Okay, we will create that functions and all, we put it into class, and after that, once we have done this, the similar data structure which is already present in STL database is called list. Then we come over to that list and we see how that list is useful for us. Any doubt in today's agenda?
No.
Hello? Okay.
No doubts.
Okay. So we'll start from the link list. I will open some Excel file to explain you. Okay. Suppose what is actually a linked list, we need to understand. Suppose we have an array. Okay. For example, we have an array. Like we have an array of these many elements, like 5 element or 6 element. Okay, so first thing is why we need to use the linked list. What is the use of the linked list and why it is required? So for example, you create a array. For example, you create an array of like 100 element. Okay, so for example, you have a static count. It means that it will not change. Suppose you have a student of 100 class, so you can make an array of 100 and you can use it. Suppose you don't know the size. For example, you don't know array size. It can increase, it can decrease based on the runtime. For example, you want this array needs to be changed, but once you have defined it, it cannot be rechanged. Okay, so what you need to do, either you need to delete it and you need to create a new array. Okay, suppose you want to use 90 persons. For example, 90, if I create this array as int of 100. Okay, so what will be the size of this what is the size of this whole array? If the integer is of 4 bytes, so what will be the size of it? It will be 400 bytes, correct?
Yes.
Okay. The problems comes is like, suppose you are using only 90 bytes. Okay, then 10 bytes will be wasted. The computer resources will be wasted. So we don't want that. We only want whatever the size is, we can able to do it. But the point is, if we have, we cannot change it during the runtime. Okay, that's why we have something called as a linked list. Okay, so how the linked list looks like? Okay, suppose instead of having 100 arrays of 100, suppose we have created a integer. We have an integer called x. Suppose an integer is x, a data is x, or I say it is a data. Okay, and I have created a one second. Okay, and I have created a pointer ptr. Okay, I created a pointer ptr, integer pointer only. Star ptr. Okay, and I've kept and I've make them a single unit under a structure. Okay, suppose I have structure node, you can say, or you can say combine pack. Okay, suppose this is our structure. Okay, so now the concept come is that this data we want. Okay, we want this data as 100 or 90, or this particular data we need, and we need in a line. So from one variable we can able to access. Okay, so what they have done is, suppose this is a structure, this is a first block. Let me make a color of this. Okay, so I am representing linked list by green. Okay, suppose this is my first linked list. Okay, suppose it has data has some value called as 50. Okay, because an integer data, correct? Hello.
Yes. Yes.
And it has this pointer ptr. Initially it is not having nothing, which is ptr, and it has nothing, is equals to null. Okay, now we have created another same type of structure. Sorry, let me make it a little wider. Okay, suppose this is another one, and I will write the name of this one because this is a structure node, na? So I will write it as structure node n1. Okay, this is n1, and here also I have created another structure, another variable I have created, node n2. Any problem in this? I can create both of them, correct?
Yeah, you can. Yes, correct.
And I have created a data, and I put data as 100 this time. Okay, and this also contain ptr?
Null.
Okay, and I can put null.
Yes.
Okay, so now in this way, if I copy this way of structure, if I copy this, Control C, Control V, okay, make it a little longer. Okay, and the same way, Control C, Control V, and here the value will be, suppose 150 is there. Okay, now see, everyone has a structure, and this is like this, and this, suppose we are still going with RR. So RR also have this thing. RR of 1 will RR of 0 will be having RR of 0 will contain 50. Okay, and RR of 1 will contain
100.
RR of 2 will contain 150. Okay, so but what will happen is, when you see the memory, suppose this is 100. Okay, this will be, because integer of 4 byte, it will be 104, correct? This will be 108 if we are talking about computer memory. Okay, this is correct now.
Yes.
What is an array? Array is an continuously block of elements. So RR0 is 4 byte, RR1 will be 1 more byte, and RR2 will be 1 more byte.
Another
So it is it is a continuous
memory location.
block of memory. Okay, but when we come over here, it should be something like 1000. It will be something like 428. Okay, and it will be like 905. Okay, so these have this different memories. Okay, so these are the memories. So now we need to mimic this one, this array in the form. So what happened when you call a function, or you try to print? So it will print this RR until and unless it find a null value over it. Suppose when the array ends, it will end with a null value. It doesn't have anything. So if you print the values, suppose you have created a string or and put it in a continuous form, but when it reaches to the null, it understands till here we need to print. After that, we don't need to print. It is a continuous block of memory. But suppose I put a pointer in this direction. Suppose I have a pointer. So now I will name as a pointer as pointer pointer 2. Okay, suppose this pointer pointing to this particular n1. Okay, we can print n1, but we cannot print n2 or n3 because first thing, they are different variable itself. Okay, and they are not connected. Okay, so what happened if I put this? I know the address of this particular one. If I copy this 428, there is no common ground of connecting between them. Now, what I do is I just have the address of other node. N1 has the address of N2. Correct? Yes. And N2 has an address of 905. N3. So, yes. So this pointer can have this one, right? If I have created a pointer and pointed to the structure node, I can do something like this, na? Pointer this and data. I can print the data, correct? I can access the data. I can read and write the data, correct now? Yes. I can make it 19, and I can access this also. POINTER pointer. This one. I can access the next PTR also. Next pointer, what it is. I can put it into somewhere. Understanding, with the help of this one, we can able to connect one node to another. So we are doing nothing, but we are connecting the addresses. Address of first node is connected to address of second node, and second node is connected to address of third node. In this way, we are able to connect the structure, and we are able to mimic the how this array is working, right? But the problem with this array is if 100 bytes are given, so it cannot, either you use 100 byte or you don't. Either you use 100 byte or you don't use 100 byte. Those 100 bytes are going to occupy memory in the RAM. Correct? So use 10, you use 20, or use 30, or use 50. Until unless you are sure, then only you can use these many values. But sometimes there are lots of variation in the values. Suppose now we require 50, next day we require 100, next day require 1000. So we cannot depend on a static value. We need dynamic. Dynamic means which can change in the runtime. So we can increase the number of nodes, we can delete the number of nodes. Okay. Any doubt till now? No doubt. Okay. So what type of operations we can have in array? What operation we can have in array? Can anybody tell? What can do with the array? Normal array. Come on. Operation with the array. Simple question only. What is the operation we can do with the array? We can fill the values. Accessing the data. You can access. Okay. Next is we can access any index. Yes. Index we can access. Okay. These operation we can do. But what we cannot do is we cannot delete any element of this one. For example, ARR2 is there or ARR1 is there. We can keep it as a 0, but we cannot delete this entire thing. There should be ARR1 will be there. If you want to delete the center one, suppose we have a 3 node array. Okay, instead of 100 we have only 3. Okay. Now you want that it should not be 3, it should be 2. Okay, so what you will do? First, you will make this ARR3 to ARR2. Okay, and you shift the element of second to first. Correct now? Yeah. Yeah. Then you can remove this thing. But it will be there until the end of the program. Okay, so that is a problem. Okay, what operation we can do with the linked list? Okay, what operation we can do? We can insert, can put a node we can put anywhere, any place. Suppose I want to put a node in between over here. So what I need to do is I need to put this pointer. Suppose I need to make a point over here. Okay, so what I need to do is I will take this. Suppose its address is 250. Okay, So what we will doing is we are changing this. We are changing this 250. Okay, and if I copy this whole, okay, and if I paste it over here, let me make it a little. Okay, and we'll make it as this. This linked list and all is all visibility. So how you can think that as you can make the program. So how we are added another node. You see, we added another node with a value 250. Okay, with 250 we changes the address. We put the address as 250 over here. Let me have this address as 2500, otherwise it will be confusing. Okay, so it address should be this one, and this will holding the next address, and this will holding the this one address. Suppose I want to delete this, then again I need to point this PTR to this 248. Correct?
Yes.
This one needs to remove. So what we will do, we'll point this PTR directly to this. We will delete this. How? Okay. What else we need to remember is that this is getting runtime memory. It means you need to take a DMA memory, dynamic allotted memory you need to take for making all of these. So how to take the dynamic allotted memory? Using new operator. Correct?
Yes.
And once you want to, so you can create a new node using new operator, and you can place it in anywhere. You can place it in front, you can place it in back, or you can place it in anywhere in the between the nodes. Okay.
Yes.
We can delete also. Delete any node. Okay. In how many way you can delete? You can delete by index. Suppose I want this second or third to be deleted, so we can delete by index. We can delete by data. Suppose I want that the particular node with 9005 needs to be deleted. We need to find this data and we can delete it. We can remove it from here. Okay, we can delete it from the back. Okay, so what will be the logic? Whatever is in the last, just delete it. We can delete it from the front. This is clear? Operations. What operations we need to do? First, we need to create a node that needs to be done from dynamic allocation. Second, for deleting, we have these many options. Inserting also we have these. Inserting also we have these options. First is any index we can delete. Insert. Okay. Data is not there. We cannot insert by the data. Back and front. For inserting, we have back and front. We can insert it at any index also. This is clear?
Yes.
Okay. So we will start from the front only, not from the back. So suppose we want to insert a new node over here. So how we can do that? Suppose here I need to create a node. First I copy this and I will take a space over here and get printed, and I will just increase the size of it. 1 second. Okay, suppose here I need to insert. Okay, so for inserting we need to know the head of this linked list. There is one variable called head. Head is what? Head is also a pointer. Head is a pointer. Head is pointing to this particular node, which means head it at the place of 1000. Okay, so I'm just explaining it theoretically, then we will see it the program. So what head is having? Head is having a memory which is holding as 1000 place. Okay, from this head, if you know the head address, you can know the PTR address. If you know this PTR address, you will know the address 2500. If you know the 2500 address, you can know the 2428 address. If you know that, you can know the address of 9005. If you know that, you can go into this last. Okay, last will take Okay, and here it is null. So if you know the head location, or if your pointer has a memory address like this, you can travel through all the linked list. Correct?
Yes, correct.
But adding in the front is very easy. Very easy is, first we need to create adding in front. What we need to do? First we need to create a node. Correct. First what we do, we'll create a node. Node means this structure, this one. Okay. After that, once you created the node, next thing you need to do is you need to have the head. And head will have suppose its memory is 500. So head will point the location of the new node. So it will be having the head. Okay. Now this particular this new node which we have, this PTR. Suppose this is a new node. New node PTR will have the value what head has before. Okay, so this would be like reverse. If I cut it from here, Control X, put it over here. So this PTR will contain the value 1000. So what head contain? Head also contain 1000 previously. Okay, so this head will containing 1000 now. Okay, sorry, this new node PTR will containing 1000 now, and then head will be containing this 500. So in this way we can add a node in the front. Any issue in this?
No.
Okay, 1 second. Let me see. Anyone has added? No, there is no one. Okay. Okay, so we'll. So this is the first one. Okay, so first we will implement this one and we'll see it works or not. Okay. So let's go to the compiler. Okay. I'm taking online compiler because it is. Okay, so I think it is loaded now. So first we need, of course, we need headers. Include IO stream. Okay. Then we will have using namespace td. Okay. So I'm writing in the C style first so that you will able to understand. Struct, we need a node, and what it will have. Sorry. Struct node. Array. Okay, so as we have discussed, it will have an data type, data, and we'll have struct node. We'll call it as next. Okay. Any doubt till here?
No doubt.
Okay.
That
So
next
first,
node point.
so we'll go back to this one. So first, what do we need to do? We need to create a node as well. You're saying something. Sorry, I missed.
No. Continue.
Okay. So first, we need to create a node. So for that, we need this head also, no? So we'll have a header also. Struct node star head, and head should be null in starting. Okay. Then we need to create a node. I will write it as creating function for node creation. Okay. And we again write struct node start create node, then this will take data. Okay, so this data user needs to give it. That's why I'm writing in the that user needs to give. Whenever this function is called, the user need to give the data. Okay, now we need to give we need to create the node. So we will need to give the dynamic memory. For dynamic memory, we need to hold the dynamic memory. For holding the dynamic memory, we will have this pointer. So we'll have new. We're having a new pointer. As you can see, we will get this thing that will hold by a pointer. Okay. So this structure node will be holding by a pointer. What I mean is new node equals to new struct node. So in C++, this way the memory is given. Okay, struct data type. So if you write is new int, so 4 byte will be given. If you write new struct, so 4 and again this structure, that much memory will be given. Okay, so we have created the memory. Now we need to fill the memory. So this new will hold the new node will hold the this is a pointer, so it is holding. So first we need to fill the data. So we'll say data, and that is equals to data, which is given by user. Okay, now, so it, as you know, it is a new node, and we yet don't have to decide what's its next pointer going to be. So we'll fill it with null. Later we will think where we need to join this next. So right now I'm making it as null. It clear?
Yes, it's clear.
Now we will return new node. So my question to all of you is, okay, so once I call this function, it will get memory in the stack, correct?
Yes, correct. We'll
Correct.
get the math.
Okay. And suppose I have created a node. Suppose I have get the memory in the stack and I have created this node. Okay, this node has been created and I have filled some value into it. But when I return this function go out of the stack, this function will go out of the stack, correct?
Yes.
Okay. So what will happen to this memory? Simple question. Suppose
yeah.
Yes. Tell me.
That memory is created.
Memory. Suppose I written int x is equals to 50. Okay. I run this function. Did I am able to get this 50 again back? can I this the life of x will be there or x will be gone?
The life of the x will be gone, I guess,
Yes. Why?
because it's a local variable inside
Okay.
the function.
Okay. And the stuck node is also local variable, local
yeah.
or global?
This is local variable.
So when the function goes off, this will also goes off.
Yes.
So how will we be able to access this data and this next?
Like struct node. This, I think, this one is global. Struct node function in data struct node.
No, this is not.
Okay.
Okay, this new node data or new node next is there, na?
Yes, sir.
If
Yes,
new
int
node
data.
is if new node is not there, how this and this will be there?
Yes, it will not there.
Okay, so then what is the use of creating this one? Okay, I'll give you a hint. Simple hint. Suppose if I make an add program. Int add. Okay, this is easy, right?
Okay.
Simple. Yes. All static variable. Int a comma int b.
Okay.
Okay. And what we do normally?
Return a plus b.
A plus b.
A plus b.
So, okay. Now what will happen? This a and b will be gone, right?
Return. We'll get the a and b.
We will have something like this, na? Int c equals to
a plus
b. Okay. So this, suppose I have one more variable also, int d also. Okay, and int d I have given a plus b. Okay. Now I will return d.
Yes.
Okay, so what will happen here?
We'll get the
d will be gone. D will be gone, right?
Yes.
But the value of d will be present in
5.
No, the value of d will be present where? In C. Why?
C.
Because we are assigning it back. Okay, but there is one more concept over here. First thing is, when you create a node, we have something called as memory organization. So we have a stack memory and we have a heap memory. Okay, so once you construct anything into a heap memory, so function will get the memory in stack, correct?
Yes.
When function goes off, the memory of stack will goes off, but function of heap will be there itself. So what you are getting is like this, as you are getting d. Okay, what d contain? 5. It contain 5. In the same way, this new node will contain nothing. It contain a number. A number is nothing but a pointer reference. Pointer reference in the heap memory where this thing has created.
Okay.
Understood?
Yes.
Now you will understand the linked list in a better format when you ask these questions. So if we have created a node, once we have created a node, next what need to we do is, tell me what we need to do the next. Once we have created the pointer, next what do we need to do? We given the memory. We need to insert in the front.
Insert the front, yes. Insert the front.
So we need to create a function. I will create a function. How I need to create a function is, so we'll have something like, wait. Why this is, okay. We'll create a function void insert in front. Okay. And we'll have something like int data. So here only we are creating also. Suppose, see, this is a function. We have not created anything because this function is not called. Okay, until and unless this function is not called, nothing is created. Suppose we have created that add function, but we have not called that add function, so we didn't get 5, correct? I created an add function, right? In the same way, we need to have a structure. We need to have a variable to hold it. Same as we have int c, which is holding the value of d. Here also we need to have a node. So we'll say node. Okay, this is a data type. Then we'll create a variable int new node, and that will be equals to what? Now here what I need to write?
No,
in
star
no
node pointer create node.
Something like this. Remember, int c equals to add 2, 3. So
create
here
node.
Create node. Very nice. Create node. Okay, now we need to pass the data. What will be our data? Whatever we are getting from the user. Data we are getting from the users. Correct. So that's now the node is created. Okay. Yes. Okay, now we need to check. There is one more thing for creating insert in front. Okay. Suppose these all things are not there. Okay. Suppose these pointers are not there. We need to check the head. If nothing is there, the head value will be null. Null. Okay. So if head value is null, so we need to attach to this one. If it is null, directly attach the head. Nothing else you need to do. We need to change this PTR, or I can say no need to change the next. Okay. Okay, so now, we'll write something like if we've already created a head equals to null. Okay. What we need to do is you need to say head is a pointer, so we directly, and the assignment is also a pointer, so we no need to have directly we can assign, then we need to return it directly. Okay. If that is not the case, if head pointer is not there, then we need to have, sorry, no, I've missed something. Sorry, this also we no need to do. This is also not required actually. We can directly do new node underscore next. You can write that thing also, that is also okay if condition, but it is not required. Anyways, if head is null, then also it is not, now it will not be a null. So what we have done is, as we have discussed over here, we will put this new node PTR value to head. Okay. If head is null, so it automatically becomes null. It's understood. If head is not there, anything is not there, head value is already null, so it will already become null. So we no need to explicitly write as null. So it will be null automatically, and head value will be new node. Okay, this function is done. Okay. Okay, let's create a function for printing. So we need to test our thing now, so that it is inserting in front or not. For that we need to have a print. So how we are going to print is void display. Print. We'll create a function list sorry, list print list. It will take nothing, it will print nothing, sorry, it will not return nothing. So we will have we need a local structure to transmit. Okay, so I have not explained you how we are going to transfer from one place to another. Suppose we are over here and we need to print everything and we need to go over here. So what we'll do, we'll have a pointer. We'll have a pointer. That pointer points to head. Okay, so we have a pointer, traveling pointer. So I will write tr, ptr. Okay, so traveling pointer first we need to have to head. Okay.
Yes.
Correct. Now,
Correct.
Now traveling pointer will be the next way. It will be equals to traveling pointer next. Okay.
Yes.
Okay. So what will next will have? Next will have 1000. It will reach over here.
1000.
Okay. Once this reach over here, then it also goes to next.
Goes to next.
To again next and again next until and unless this travel PTR become nulls.
It points to the next node.
Yes.
Okay.
Yes. For example, if he reach over here last, yes. Okay. So what will this will become? This will null. Become TPR equals to TPR next. So TPR next is null. So null. TPR will have null. So when it has null, it will not move ahead. So this function we need to write.
Got it.
So for this, we need to create a temporary pointer, traveling pointer, you can say. We have this temp. So we have created same structure node. Okay.
Yes.
And we are equating it to head because it all starts from head. Okay. So we'll start from head and we will have a loop while temp is not null, sorry. Temp is not equals to null. If this condition is true, then what we will do is we'll have cout. Okay. And we will have a space after a space because we need a space between the elements, right? And we need to write temp and we need to print the data. So data again handle is completed. Okay. Once we have printed the data, now we need to change the temp. So temp equals to, tell me, temp equals to temp next. Correct na? Then only it will change the address. Presently temp will have 250. Sorry. Temp will have 500. Next temp will have
1000.
Then temp will have 250. So next value should be given to temp.
Yes.
So how the temp next value will be? Temp next. So we are the value of the pointer which is present over here, we are transmitting into it.
Yes.
Clear na?
Yes.
Okay. Once it is done, so this is complete. So we'll write cout. We'll write as end of the list. Okay. And after end of the list, we will have end L. Okay. Any problem in printing function, front function and printing function? How many function we have created? 2 function we have created. What and what?
Print function
and insert in the
node.
front.
Yes.
Create a node. These 3 functions we have created. Creating the node,
create node,
inserting in the front and printing. Okay, so we have lots of operation, but before validating or before going to for example, if you're writing a professional code, you have to write 1000 line of code. But if you have committed one section, if you have completed one section, first check that one section. Okay, if you find the error, you can resolve it easily. But if suppose you have written 1000 line of code or like 200 line of code, then it will become difficult to understand where the problem is. Okay, so meanwhile, when you are developing code, check in the middle that the code is going in the right direction or not. Okay.
Okay.
Okay. So first, what we need to write? We need to have insert in the front. So we'll insert 10. Okay. Let's make of insert in the front. We'll make it as 20. And again insert in the front. Let's make it as 40. And again insert in the front. And make it as 30. Okay, so we have created a list which is 10, 20, 40 and 30. Okay, so this we need to print. So we'll have this print list.
Print list
we will call. We'll run the print list and we will have this return 0. Okay, now it's time to test if our work there's no error or something we have missed, or terminal it is not running. Connection and this compilation error I have the first time in my life. Okay, we'll see. We have not done this thing. Let's see.
Yep.
Okay, if it's creating an issue, then we have Control C. Okay.
Oh yeah, it's
okay. So what is it printing? 30, 40, 20 and 10.
20 and 10.
So how it needs to print? It needs to print in this manner only, correct? Or it should be in opposite manner? We are inserting at front.
Front, yes.
Okay, suppose we have insert only 10.
10.
First we have insert 10. So I will make a new Excel for you. Okay. Understand, this thing is very important to understand. Okay. Suppose this is your Control C. I've done. Suppose I have started from this K, we can start. Okay. Suppose this is the first one, Control V. Okay. So this is how much? 10.
10.
1 second. This is 10. Now, this is the first one. Now we have pushed 20. So, here it will be front or here it will be front? Where the front will be?
Front will be
this side. It should be K or it should be L? It should be M or it should be I?
It should be I, front, because it's front.
Okay. Sorry. No, it's not working. Okay, so this will be
20.
20. Now it will come here. It will be 40. It will be
next 30.
30. Where our head should be?
That should be 30.
Okay, so how the print should come? 30, 40,
30,
20
40,
and
20, 10. It's correct.
It's correct only now?
Yes.
Okay. Okay, now you will tell me how to add at the end. Suppose I want to push at the end. I need to create a function.
Why?
Think. I'm giving you time. I will write the function name till then. Okay. Just tell me the logic. I don't want the correct implementation because implementing a linked list is a little difficult task. So this will be the same, the way it is taking, correct? Okay. We can go back to this diagram. Then we can think. Okay. Suppose you are over here. Okay. And you need to add over here. Suppose you want to add 50 over here. So what you need to do is, you are over here. So you need to travel. You need to travel till here.
Okay.
Correct? Once you travel till here,
Head directly points to end node, right?
Yeah, directly we cannot point. No, our yes, it's noting the first one, not the last
yes.
one. We need to come at the last one. Suppose this 50 is not there. Remove this 50. But you need to add over here. So you need to come from here to here. Okay, so how you can come from here to here? Using what? Temp variable.
Using temp variable.
You can come till here. What we have in this node, we will have a data and we will have a next pointer.
Next pointer.
Okay, and suppose you are temp, you came over here. You are temp and you came over here. Now you need to go over n. Suppose you need to go over n, you need to create a node. Suppose you have created a node. First you need to create the node. Creating node will be same as before. How we have created node? Using the function. Okay. So first step will be same as adding in the front. Okay.
Okay.
Suppose how I will go back to the program. Okay, so for how we have first thing, this will be same. Correct?
Okay.
First we need to create the memory, then only we can link it. So first we have created the memory. Okay.
Yes.
Okay. Now we need first to connect. What to connect? Here what we are connecting is we are connecting the new node next to head. Okay.
Yes.
Right now we don't need new node next. We need the previous one to connect with it. Understand things. This is the previous one. Temp is our previous one. Now what we need to do is, suppose this node we have created. Okay, this node we have created. I will write as node, new node. This new node we have created, and this new node we have filled data like 30. Like 50 we are going now. So we have filled data 50. Okay. Now it has some address. For example, it has an address of 7000. Correct? These three things we have. We have and it has its pointer. It has a new node hyphen tm next. Next we have. So okay, so this is the last one. Correct, na?
Yes.
Sorry. So this is the last one. So we don't care about this next. This next should be null. We don't care about it.
Yes.
Okay. Okay. Now the point is we need to connect this next to this one. We need to connect it like this. Correct, na?
Yes.
So we will have like temp. I'll increase this one only. Excel is not working that well. Okay. So what it is, this is temp next. Temp next, you have reached to here. You can go to temp next, correct? This should be equals to
previous node.
This 700. New node address, correct?
Yes.
How will you get this address?
Using previous node.
No. How you can get this is new node, na? Previous node.
Yes.
Previous node. You are over here. You need to connect it. See, understand this thing.
Use new node.
See, head. Suppose last time we have this head. We have yes. So this new node variable will contain the address 700. So we've connected the head with this thing. Now we need to. This new node will be your address, new address, because it is returning what? It is returning the new node. So you can directly put. So what you need to do is, you need to write next temp, the last, whatever the last you got. First you need to you need to travel. How you travel, you have seen in the print statement, how you travel. Correct? While loop you will put and you will travel till here, till you will find the null. Once you find this thing as null, what you will do? You will put this new node address. So you will simply write new node.
New node.
Same only one loop will be added. Nothing else. Okay. But there is a point, if it is a first one, then you don't need to do this all the steps.
Okay. Understood.
Okay, so in this first we need to check if it is new or not. Then we need to define. So first we will do this one. Then we will check for it because it will confuse you otherwise. So first we will create a node. This node have this value. So this is the address where the new node is present. Okay.
Okay.
Okay. So what we need to do is we need to connect. We need to connect the temp variable.
Temp variable.
Next.
Expression.
Next.
New. Next.
Next.
Equals to new node.
Next. Yes. Equals to
new node.
New node. Okay, now, but it is, we have not traveled yet. We need to travel. How we are going to travel is
Using while loop.
While temp
not equals to null.
No. Temp not equals
Temp
to
not
new. Temp
new,
next. We no need to go to the till end. We need to check till where the next is not equals to null. There we are checking till new is not till that particular variable is not equals to null. Here we are only here we are only checking. Okay, so once we find this, okay, now this is this one, and temp value will be, so we need to do this also. Temp equals to temp hyphen next. Okay, once we get over there, this will become new, and need to make a loop for this. Okay, this is done. So this we have created, that once we find it, we need to replace it. This is done. Now before that we need to check a condition also. What condition? If we cannot add in end if something is not there. Suppose there is no node, how we are going to put it into end, right?
Yes.
You cannot travel as well. There is no need of traveling also. If something is not there, how you can travel? So we need to check that if had is yes. If that is the case, then directly make this as a new node. Put had as a new node. Okay. And from here only you will return. Okay. Something like this. Okay. I think first we will run it if any compilation errors are there. Don't think we should have any compilation error. Hello. What we have missed?
Line number 24.
Okay, I think we have not given this variable name itself. Struct node temp, right? There is no temp name variable. Struct node star, because it's a local variable, right? We need to give the name temp. Sorry, not 0. We need to make as, we'll make it down this, Control X, Control V equals to. You understand why I have written this line? Hello? 40 is an error. Why 40 is an error?
Line number 24.
Line number 24. What is wrong in line number 24?
Insert.
Oh, that is. Oh, sorry. But I have not written the function name yet, na? This should not be in compilation error. Sorry for the insert. We're getting compilation error. See, Something bracket or something is missing. This bracket is completed. This bracket is completed. This extra bracket somehow. Remove this bracket. Let's see. Yeah. Okay. So now we will print insert E and D and okay, and we'll put something like as 50. So how it should come?
It should come like first head 50.
No, it's in end, na?
And yes.
Then
30,
think what?
40, 20, 10, and 50. I think.
Correct.
Yeah, 50.
So first it will. I will just comment this one. So let's run this. Some issue. 1 second. Create in this one. Not working over there. Let's try over here. Okay. Mostly use online terminal because it is visible. Visibility is more over online terminal. Did I saved it or not? Yes, I saved it. Control X. Okay. It's okay. Let's see. Its visibility is clear for you. It's taking more time.
Yes, sir.
It's taking that much time. Missed something. Is written some infinite loop or what? Let's check. While oh, compiling. Sorry, if it is running, then it's okay. But why it's compiling taking time? Once, wait a second. Let debug this thing. I think something will return. Return nothing returning. While is okay. Okay. I print something over here. Let's see. See out. Working fine. And night run. Other than this, I don't feel anything is. Oh, fun actually. Why? Question.
Devans, I think your voice is not coming proper.
Hello.
Yeah, Devans, your voice is not coming proper actually.
Okay. 1 second. Ping.
Some interruption still is there.
Okay.
Now it's fine.
Now it's correct.
Yeah, now it's fine.
Looking into this one. What is
Still
creation
someone
of
is
no? Yeah, I'm not speaking actually. In the code. Uh, in create also we have created this as null only, na? So at a point it should come null. While temp is heading to head. That's correct. And while temp next is not null. Okay. Wait a second. Okay, guys, we will see it tomorrow. I don't know what is the issue. So we'll connect
Hello?
tomorrow. Yeah, hello.
Yeah, tell me.
Yeah, I'm saying we'll connect tomorrow. I will see
Okay,
what is in there. So we'll connect tomorrow. Okay, so I will share the code. If you find this any bug into this, why it's not coming, it's going I mean infinite. So we need to check some pointers we are missing. We'll check it and we'll continue over it. Okay, I will share the code. Wait. I was sharing the code in the group. I think I have copied it. Okay, so we'll connect tomorrow and we'll see it. Thank you.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.